Okay, so far I have started with the what is Hadoop. So HDFS and MapReduce. So HDFS part I will take it separately. What is the architecture of HDFS, and MapReduce is the computing part. So MapReduce is having this classes, driver class, mapper class, reducer class. So I will tell one session for the MapReduce, like how the MapReduce code we write, and MapReduce is only just for understanding, right? Nobody is asking interview point of view. Nobody is asking question in MapReduce, but it is just understanding point of view, like what is the MapReduce framework. Okay, and another tool is there in Hadoop, that is Hive. So Hive is, it's a SQL data warehouse tool. Okay, so we can say like what queries we are writing in RDMS, saying we can write SQL query in Hive, and that is called Hive Query Language. Okay, HQL. So we write HQL files. So we create a HQL file like test.hql. Like this file I'm creating with HQL extension, and this file I'm writing some SQL query like this: select start from employee. Okay. So once I write the SQL query in this HQL file, so I will run this HQL file using the Hive command. So on the $shell, I can run Hive -f, and then I can give test.hql. This is the one way to execute the Hive queries. Another way, we can go to the Hive shell directly. So we can start Hive and we can go to the Hive shell, and there I can run directly select start from employee. Okay, so that I will tell in Hive. For Hive, I'm just going to tell you what is Hive and what is the purpose of Hive. And Hive we will use most frequently whenever I have to read the data from the database, right, in Hive database. Okay, so Hive is having one more thing is meta store. I will tell what is a meta store. So meta store is one database is there, one database which is storing meta information about the tables, meta information about tables in Hive database. Okay, so there are three types of meta stores are there: local, embedded, and remote. Embedded and remote. I will tell more detail about this meta store. Okay, Pig is another way of analytics. So what we do in Pig, basically we write Pig Latin script. Okay, it is completely ETL kind of tool. ETL tool. It is completely ETL tool. Extract, transform, load. ETL tool. So suppose I have to read a file, and iterate a file data, and then store output into some other file. So basically we will write command like this. First we will write load and give the path. Suppose my path is /home/test/xyz.txt. So I have read the file using the load command. Then I will use iterate command, and basically I have to assign a variable here. So I will say a equal to load. Then I will say b equal to iterate a, and what output coming from the iteration, we say dump. We can store b into some location. Location is /home/test/xyz1.txt. So like this we have to write ETL script. Okay, this is Pig Latin script. But nowadays nobody using the Pig, because mostly analytics we are doing either Hive or Spark. Okay, so why we are not using the MapReduce? Because MapReduce we have to write use code. Suppose I am writing a driver class of 50 lines of code. Okay, and I say mapper is also approximate 75 lines. Okay, and the reducer class is also 75 lines. So this much of lines of code, if I'm writing in the MapReduce, same thing in Hive, I can write one single line of code. Okay, hardly 2 lines of code. So whatever code I'm writing here in the MapReduce to process on analytics, that code I can write in Hive, only single line of code. We can write select star query command. Okay, so it is making productivity very higher. Okay, and Pig also we have a less code, but it is not lesser than the Hive. Okay, so productivity wise, if I compare in MapReduce, MapReduce is having less productivity. Okay, if I say Pig is the second number and Hive is having the more productivity. Okay, so the Hive is having the greater productivity. Like we have to write less code means productivity is high. Okay, Hive we are writing less code, and MapReduce we are writing more code. That is the one difference. And another one is, for MapReduce we need a Java knowledge, and Hive we need SQL knowledge. Okay, so that is any person who is having a SQL background, he can write SQL queries. But MapReduce is we need to write a complete Java code. So that is another difference. And Hive we can say we can use any kind of functions and anything, like whatever we can use in SQL, we can use in Hive. Okay, so Hive is giving the benefit of distribution of the data across the cluster plus SQL behavior. Okay, so Hive is having some other benefit, so that I will tell. Like Hive is having a CLI mode. Okay, we can write a query in the command line mode. Hive is having a thread server. Thread server is basically sometimes I need to transfer my data from Linux to Unix, right? From Linux to Windows, right? So how can I read the data? Okay, so in that case I will use thread server. Okay, and thread server is providing the JDBC ODBC driver that can connect from Windows to Linux. Okay, so there we need Hive driver. I will tell about Hive driver we need, and we have to write one Java program. Hive JDBC ODBC driver to connect Hive database and get the data. Okay, some Hive is having external table, internal table concept. I will tell all those things: internal table and external table, internal table concept, how to create external table, how to create internal table. Okay, so those concepts are there in the Hive. It is clear so far, right? What is analytics tools are there in Hadoop? So one is MapReduce, one is Hive, one is Pig. Is it clear? So Hive, this is analytics part, but we need to do ingestion, right? We need to do ingestion of the data. So what is called ingestion, right? Ingestion is bringing data to Hadoop file system. Okay, Hadoop file system. So what are the different ways are there? Okay, so ingestion process are the two types. Like we can say one is structured data ingestion, and one is semi-structured and unstructured data. Okay, now the question comes, what is the semi-structured, what is the unstructured data? Okay, so we say like structured data is a simple format data, right? Like I say name is there, age is there, date of birth is there. These are primitive data. These are simple primitive data type data. Okay, I say name is string. Okay, age is integer, DOB is date, right? So these are the primitive data. So this kind of data is called structured data. So data is having the dimension. Data is having dimension, right? This is a one dimension is there, one dimension. Okay, so this is structured data. Semi-structured data is data is in the file system data. Data is file system data. Okay, some examples are like CSV, JSON, XML, and email. Email is unstructured. So CSV, JSON, XML. So this kind of data is called semi-structured because the data is in file, but data is having the structured data in a file. That is called semi-structured. One is unstructured type data. Unstructured data. So we know, right, audio, video, and pics, photos. So these are called unstructured data or email. So why email is unstructured data? Because email is having subject and body is structured. Body is using structured data, but attachment is some file. Attachment is some file. That is semi-structured. Okay. So when we are doing the ingestion of the structured data, so we have to use a tool like Scoop. Okay. When we want to do ingestion with the semi-structured, unstructured data, we have the tool is Flume. So these two are the part of the Hadoop ecosystem. So Hadoop ecosystem is having these different tools. Hive is there, and HBase is there, Scoop is there, and Pig is there. So these are the part of Hadoop ecosystem. So when I talk about like I have to bring the structured data using Scoop, so basically I am bringing the data from the RDMS. So when I am bringing RDMS to Hive or SDFS or HBase. So this is called Scoop. That will be coming through Scoop. So I will tell the Scoop command how to bring the data from any RDMS database. So this RDMS database may be Oracle, MySQL, or we can say SQL Server. Any database we can bring the data into Hive, SDFS or HBase. Suppose I want to bring some file like some JSON data, CSV data, or Twitter data. Twitter data is again JSON data. Okay, I want to bring into the SDFS. I will use Flume. Okay, so Flume is one tool that is used for semi-structured or unstructured data. Okay, so this is called ingestion of the data. There are two ways. One is using the Scoop, and another way is Flume. Scoop does for structured data, and Flume does for semi-structured and unstructured data. Okay, so here we have seen so far what are the Hadoop ecosystem components are there. Okay, now next thing I am talking about what is the SDFS architecture. Okay, so in Hadoop there are two major components. One is SDFS and second one is the MapReduce. Okay, if I divide SDFS, there are two parts: name node and data node. Okay, so there is a pretty simple definition. Name node is master node of Hadoop system and containing metadata about all data nodes. Okay, so it means one master node will be there. One master node is needed. Okay, and this master node having all the data nodes metadata. So what is metadata? So this metadata is nothing but is basically is the data node IP. How many blocks are there? Okay, now new concept is coming from block. So what is a block? Okay, suppose I am storing data in GBs, MBs, right? PBs and petabyte PBs. Okay, in SDFS, right? So Hadoop distributed file system is a kind of file system. File system is where we are storing the data in the files. where we are storing data in a form of file. Okay, so when I'm talking about the file, so definitely the data will be either GBs, MBs, KBs, like that, right? So I say the fundamental unit of SDFS is block. So block size is, so there is a block, and block size is either 64 MB or 128 MB. Okay, so when I talk 64 MB, this is for Hadoop 1.x version, very old version, Hadoop 1.x. Now the 128 MB, this is designed for Hadoop 2.x, like 2.7.5 version. Okay, but now the latest version of Hadoop is Hadoop 3. Okay, Hadoop 3.1.0. Okay, so that is also using the default size is 128 MB, but it is configurable. Means we can change the block size based on our requirement. So why is this block size so much higher? Because if the block size is higher, it will be less number of blocks and we will be able to read the data faster. So if I will say, so why we say Hadoop is meant for very, very large file, Why we say like this? Because if the files are very large, and our block size, files are very large, but block size is small, then what will happen? There will be more number of blocks needed, right? To read the file. So it will take more time. Okay. So Hadoop system is designed for large file. Larger block, to read large file. Okay, in Windows, the block size is, can you imagine the block size is only 6 KB, and Linux block size is 6 KB. So if this size of the block can be read a very large file in Windows and Linux, we can't read. It will create more number of blocks. So Hadoop is very good fit for large files like TBs file, GBs file, petabyte file we can read. Okay, it will take time, but it will allow. It will not be give any issue. Okay, so here is I'm talking about the name node. So name node is a master node of the Hadoop file system, and it is containing the metadata, which is the data about data node like IP, how many blocks, and the replication. Replication is replica copy. So suppose one block is one node, it will have the 2 more copies in the 2 more machines. So that kind of thing is called replication. So how can we increase or decrease the replication factor? Okay, that I will show in Hadoop command. So metadata is basically information about the data node. So second thing is the data node. So data node is actual node which is containing data, Okay, and so basically, who is the master? Name node, and data node is slave. So name node is sending heartbeat every 30 seconds, heartbeat to data node to send every 30 seconds to check whether data node is alive or not. Why it is doing so? Because suppose data node is down or data node is not alive, okay, or data node is crashed. So what name node will do? It has a replication factor, right? It has replica. It has a replication detail. It will allocate another data node for the same block. Okay. So if one particular data node down, so that data node block it will allocate to the another data node. Okay. So suppose I am reading or writing a file. Suppose I am reading or writing a file, writing file in SDFS. Okay. So what internally happens? Suppose I am saying I'm a client, and I want to read a file. Okay, and my file size is 1 GB. Okay, so when I'm reading this command, Hadoop fs minus get, and then I say the file name. Okay, and then I give my local directory. I say my local directory is home/test, and here I want to get that file test.txt. Okay, so this test.txt file, when I want to get, what Hadoop will do, Hadoop will find all data nodes IPs from name node. So first of all, who will get the request? So Hadoop will send a request. Hadoop will send request to name node for this particular file to read and find all data node IPs for that file, and give direct access to client. Okay, then client will be able to read the data. Client will be able to read data. Okay, but suppose one thing happened here. One particular node block is not accessible. While reading the data. Then name node will assign another replica copy of that data node block. Okay, so this is actual way. Same way, when client is requesting writing a file, in SDFS. So what command he will use? He will use Hadoop fs minus put or copy from local. He will give the file name and give the Hadoop location. So Hadoop location is I say some user location, user/test. And here I am writing a file is a.txt. Okay, so when I am writing a file, so Hadoop will find this request will go to the request will go to name node, and the name node allocate name node will allocate data node locations to client to write the block. Okay, so once it is done, then it will be written to client a message, file is written. Okay, so this way reading and writing happen. Okay, so this is SDFS architecture. So SDFS is having two parts, master node and the slave node. Master is name node and slave is data node. Similar architecture, master slave architecture is there in the MapReduce. So MapReduce is having the two components. Okay, one is job tracker and task tracker. Okay, so job tracker is a single entry point. Like job tracker is master. Which is allocating task to task tracker. Okay, so when we are writing a file, who is doing the actual writing part? So task tracker is doing actual writing part. Who is doing writing part? In data node block. So task tracker, job tracker is assigning one writing task to task tracker, and task tracker will be doing task on data node. Okay, and who is instructing to the job tracker? Name node is instructing to job tracker to assign job. Okay, assign, we can say the task, and that task is given to the task tracker. So it means name node is one machine. Okay, and it is a single point of failure. Single point of failure. If this name node is down, entire cluster is down. It is down means entire cluster is down because we can't access anything. Entire cluster is down. But Hadoop 1.x and 2.x is having the alternative for that. So Hadoop 1.x is having secondary name node concept. Secondary name node concept that is similar to name node, but it is activated when name node is down. Okay, but it is taking the data, but it is synchronizing the data. It is synchronizing metadata which is stored in name node to secondary name node. Okay, so same thing in Hadoop 2.x. Hadoop 2.x they have given the concept of active passive name node. Passive name node. Okay, so another name node will be there, but that will be passive name node. So here one drawback was there in the secondary name node. The drawback is it is synchronizing data every 30 minutes. Okay, so we will get the data late of 30 minutes. So okay, the last 30-minute data we will not be able to get. We will not be able to get last 30-minute data. Okay, and it is taking time to activate in 30 minutes. So that is the two drawback. So Hadoop 2.x they provided passive name node. So one active name node is there, one active name node and one passive name node, and both are having the same configuration, one passive name node. Okay, so here is one advantage. If active name node is down, then passive name node will become active in 1 minute. Will be active in 1 minute. Okay, so that concept is there in 1 minute. That concept is there, the passive name node concept. Okay, that is high availability concept. High availability in Hadoop 2.x. Okay, somebody asked like what is the high availability in Hadoop 1.x? We have to tell about secondary name node concept. When somebody asks about the Hadoop 2.x high availability concept, so you have to tell about active passive name node concept is there. Passive name node concept is there. Okay, so we can do this way. So here is basically this is all are the storage part. Okay, now we were talking about when we are talking about MapReduce, right? The MapReduce is having the job tracker and task tracker. So job tracker is master, task tracker is slave, and job tracker is allocating tasks to the task tracker. And one more thing is there, if task tracker is down, so job tracker will find another task tracker where the same block of copy is there. So basically where okay, so name node is on one machine will be there, and job tracker on one machine will be there, or job tracker can be on same machine of name node. So these are basically the services. Okay, name node. So total how many services are there? So total 5 services. Name node service. When we start Hadoop using this command, start -all.sh. So how many services will start? Name node, data node, secondary name node, job tracker, and task tracker. Okay, this thing I told you in Hadoop 1.x. In Hadoop 2.x, suppose I am using Hadoop 2.x, so there is some differences there. Name node is there, data node is there. Okay, secondary name node is there. So secondary name node concept is both, right, in Hadoop 1.x as well as 2.x. Okay. but mostly we use active passive name node. And here is job tracker. Instead of job tracker, here is a resource manager. Resource manager, and instead of task tracker, we have node manager. So what we call it here job tracker, the same thing is a resource manager, and here we have task tracker, that is called here node manager. So resource manager is having a two roles. One is managing the resources, and second one is processing part, right? Like the map reduce. Okay, map reduce, like we can run the job, map reduce, and hide and take the jobs we can run, can be done, or anything can be done. Okay, so here is extra responsibility is there in the Hadoop 2.x. Resource manager is managing the resources, like how many memory resources, CPUs. Okay, so those things will be allocated by the resource manager. Okay, and node manager is same like a task tracker, only doing the task on data node. Okay, data node. So name node is on one machine. It is a single point of failure. It is down, like then entire cluster is down. But we have the way in Hadoop 1.x and 2.x how we can right now avoid this single point of failure. Okay, or we can, if the single point of failure means if anytime name node is down, it will be giving an alternate for that. Okay, it is on the entire cluster is down. Okay, and job tracker on the same machine, or it can be on a different machine, but the data node plus task tracker will be always on the same machine. Because wherever the data node is there, same machine, the task tracker will be there. Or we can say resource node manager. Okay, job tracker is a resource manager. So this is a high level concept I told about, and there is some other concept is like how the data is stored in the racks, and what are the other policies things are there, what is the configuration file is there. So this all things are understood about this basic concepts. I'll give the PPT for that, so that will make it more clear, right? Like these are the new concept maybe for someone, but maybe somebody already gone through this basic fundamental concept, so it will be easy. But someone who is going through first time, it will be little bit not very easy in the first time, but when you go through again and again the same concept, it will become more familiar. Okay, so I will give the PPTs and notes, right? So that will make you clear all those concepts. Okay. So this why I started this, because I thought like first with the basic fundamental concept things, like some more fundamental things are left, like Hadoop commands, like SDFS command, like suppose how to write a file, how to write a data in SDFS, how to read data. So those are day-to-day commands we should know. Nobody will ask in interview, but those command is for working purpose, right? Like if you are working on the Hadoop Spark environment, so day-to-day, like you are writing the file, you are writing the data, you are reading the data in SDFS, you are whatever Linux command you know, same Linux command you will use in the Hadoop. Okay, so ls command, rm command, okay, chmod command, everything, like whatever command you use in Linux, same command we will use in Hadoop. Okay. So any question, any doubt?
No.
Okay, it's clear, right? Okay. I'll share this notepad. Okay. So you can go through once again. But more clear notes I will give separately, which I have. So you can understand the same concept, whatever I have told here. So you can go through once and then understand. Okay. So the one, okay, how we will start, this is a Hadoop fundamental thing. So Hadoop fundamental concept, what we will see next, that is basically SDFS command. Okay, so SDFS command I will tell, developer command and admin command. Okay, So generally we are not dealing with admin command, but some of the admin command we should know. One safe mode command, I will tell in admin, some statics command and some quota command, like how much and how to know the status of our cluster. So everything we can see through admin command. But developer command are basic commands, and those are day-to-day life we use. Mostly get, put, ls is there, and rm command is there. Changing permission is there. Ch mode is there. Ch on is there. Honor we want to change, and some more command is there. One is get, put, ls. So these are having the various other categories are there. One is if I want to find the size of the file or directory, the bus command is there. Okay, that I will tell. And suppose I want to see the last content of the file, the tail command is there. So this command we can use in the SDFS. Okay, and admin command is there. After that, I'll tell about MapReduce concept. Okay, so MapReduce concept, right? How to write one word count program in MapReduce. So what are the files are required? Driver is there, mapper class is there, and reducer class is there. So I'll make you understand the code. Okay, code I will make you understand how to write in Eclipse, or and IntelliJ. So two IDs we use. One is Eclipse and one is IntelliJ. So these IDs we will use for the Spark also. Okay. So generally IDs are basically editor, right? We can write a code, and we will use either MapReduce or we will write the code for the Spark. So we are using the Spark Scala, so we can use in IntelliJ, even Scala, Eclipse also we can use. So any one of the editor we can write code. Then create a jar from code and submit on the cluster. Submit on cluster using Hadoop jar command. Okay, to run MapReduce word count program. Two ways are there. One is using creating a jar, and second way is running word count program in Eclipse itself. Word count program in Eclipse or IntelliJ. Okay, two way. Generally, Eclipse or IntelliJ we use for testing purpose. Because if you are creating a jar and submitting on the cluster, it is expensive, right? Because we have to create a jar again and again and submit on the cluster. Better is we test once in the Eclipse and IntelliJ. Once our code is tested, then we create a jar and finally submit on the cluster. Okay. So testing part we run locally in our Eclipse or IntelliJ editor. But once our code is tested, like our code is giving a correct result, then we create a jar and submit in the cluster using Hadoop jar command, and we can get the output in a Hadoop. Okay. Then we get word count output in Hadoop. Okay, we can get it. So this is the two ways. So this is a MapReduce program. So in MapReduce some more concepts are there. One is map site join. Okay, I will tell what is a map site join, and it is distributed caching. Okay, and some more concept is there in the MapReduce is we have reduce site join. Okay, so map site join we use like when we are having two data set. Can Hadoop maintain a number of cluster? Hadoop maintain a number of cluster. Okay, so can Hadoop maintain a number of clusters? So yeah, cluster can be any number of clusters. Okay, but every cluster will be one cluster to another cluster we want to connect. We have to use one Hadoop DistCP command. Hadoop DistCP. Suppose I want to transfer the data from one cluster to another cluster, I have to use DistCP. Okay, another cluster. But suppose in the same cluster, if I want to move the data, then I can use Hadoop commands. Simple Hadoop SDFS command. Right? Copy command, move command, okay, MD command or put command, those we can use. But when we have two clusters, so you can see the example of the number of cluster means, suppose I say dev cluster is there. Dev cluster is dev environment. Okay. that is a separate cluster. Suppose I say this cluster is a 4-node cluster. Okay, 4 node, 1 is a master node and 3 are the data node. Okay, this is a one example, one cluster. Another cluster is QA cluster. So QA cluster, I can say it is a very small cluster for QA purpose. Okay, just testing purpose. So I can say it is a 2-node cluster. Okay, one master and one data node. Okay, that is a one example. Then I say UAT is there. So UAT may be big, right? UAT and production. So these cluster will be very big cluster, production, because the data size will be more. The data size will be more on these cluster. Okay. So it depends, right? How big organization is, how big data size you are getting. Generally, the dev cluster and QA cluster is for testing and development. But UAT and production is once your code is finalized and you want to move it to UAT, and UAT testing will be done, then it will be going to the production. So production is final one, right? When end user is testing, end user is using in the production. Okay. So these are the different types of clusters, but you want to move the data from these clusters, you have to use DistCP. So from one cluster to another cluster, you want to move the data, you have to use Hadoop DistCP. But the same cluster you want to move the data or copy data, you have to use Hadoop HDFS command. Okay. So generally the cluster means it's a number of nodes. One cluster having the number of nodes. So we will create based on our requirement the cluster we will be creating. So some companies have 3 clusters, 4 clusters, or maybe only 1 cluster. Okay. So they have everything in the same cluster only. Okay. It's fine. Your answer. Okay.
Yes, sir. So actually, it's in the environment, right?
Yes, the environment only, right? So generally, you will not send your final code. You will not send your code to the production directly, right? You have to commit the code in the dev and dev to QA, QA to UAT, and UAT to production. This is a life cycle, right? So once the code is tested in one environment, then the code will be promoted to the next environment. And okay, sometimes the QA and dev is only one environment because they don't need a separate one QA environment, right? So dev and QA both are same. But UAT and production, that will be different, okay? Because UAT is similar type of production, not exactly production, but it is same configuration of the production. Because UAT means we want to analyze it, the similar simulation of the production, right? So whatever issues are coming in the UAT, the same issues will come in the production. So we can easily fix it, right? So suppose in production, I got some issue. So first we will replicate in the UAT. If UAT that issue is replicated, then it is given to the dev. Okay. So UAT in production is having the same configuration. Okay. But actual user will be using the production, not UAT. But UAT is meant for UAT testing, right? User acceptance testing, right? That will be final testing before going to the production. Okay. So this all this comes in the DevOps, right? This is not part of the big data. Okay. Big data means we are development. Big data, we are doing the development. But the same code, everything is going to the different environment. That is the reason this environment is coming in picture. But this is more related to DevOps. So this environments are related to DevOps, right? DevOps is having Git is there, Jenkins is there, and you heard about Docker and Kubernetes, right? So this is creating the clusters, Docker and Kubernetes, right? So this is like infrastructure creation, okay? And this is making your infrastructure creation automation is very easy. Automation is very easy. Okay, like whatever code we are deploying in the DAG, it will be promoted by automation stepwise into the QA to UAT. It will be very easy by using these tools. Okay, so Jenkins is having the CI/CD pipeline. Okay, Jenkins having CI/CD pipeline. So these things you can separately learn basics only. No need to go and dig because nobody will ask you much deeper in these tools. But at least you should be aware of these tools like Git is code commit and like you are checkout code from the repository. So you use Git. Okay. Okay.
Yeah, sure.
I'll show the git commands. Okay, git Jenkins. I will give the one basic sections, right? Like how to see this all tools, right? Even these are not related to a developer, a big data engineer, but at least for knowledge point of view, you should be aware of what is the functionality of these other tools in the DevOps. Okay. Okay, so I was talking about the MapReduce concept, and then I will switch to the next thing is Hive. Okay, Hive is important because mostly questions like now, if I say in an interview, now mostly questions I say 50% part is, or we can say 40% part is this Hive, and Spark is a 60%. Okay. Okay, and other tools also there. Sometimes they ask questions in the scoop and those things. So Hive, scoop, all those things are 40%. Hive, scoop, HBase, whatever Hadoop related part, and whatever Spark is, that is 60%. Okay, so Hive is one analytics tool. Scoop is ingestion tool, that is import tool, scoop import, and export tool, and HBase is a NoSQL database. So we already know some databases are there, NoSQL databases, Cassandra and Mongo. So it is the same category of the database, Cassandra and Mongo. So these are the two popular databases in the market, Cassandra and Mongo. So similar type of tool is provided by Hadoop, that is named as HBase. Okay, so HBase is a column family. HBase is column family. I'll tell what is a column family means. Like some columns you can group together in a single type of columns, so that you call column family. Like suppose I say personal information, but personal information may have multiple columns, right? Name is there, age is there, okay, I say date of birth. But those all three are related to single column family, that is called personal information. But they have separate three columns. So this kind of requirement is there, then we can go for HBase. Okay. Other benefits are there of HBase because it's a NoSQL DB. It's a NoSQL DB. NoSQL, not only SQL DB. Okay. And Spark is a processing engine. Okay. So Spark is having a Spark core. 3 module is there. Spark core. Other are there, but we will use 3 as a developer. Spark core, Spark SQL, and Spark streaming. Other one is Spark ML is there, ML lib, machine learning, but that is mostly for the data science people. And it's Spark ML lib, and Spark graph. Okay. Spark graph is like we can use edges and vertex, right? Edges and vertices. Okay, like if you want to find friend or friend, if you want to find like in Facebook is using this Spark graph. Okay, we want to find friend of friends, friends of friend likes. Okay, so this Spark graph is good. Spark graph. Okay, and one more NoSQL database also used for this kind of functionality. That is Neo4j. Neo4j. So Neo4j is a NoSQL DB for graph type of requirement. Right. Okay. So I will cover first the basic fundamental Hadoop HDFS command, MapReduce concept. Okay, MapReduce concept, map side join, reduce side join, Hive, and then scoop HBase, and then Spark. Okay. So I will start tomorrow HDFS command. I will first finish this HDFS part tomorrow, and then I will start the MapReduce because it will take 2 to 3 days. Then I will start the Hive. Okay. Okay, we'll plan this this whole week. We will finish it this till MapReduce. So then we can start Hive from the next week. So you will be ready for understanding the concept of Hive. Okay. Yeah. Okay. Any question is there?
I'm good, Arvind.
Yeah. Okay. I'll share the recording and get more practice. Thank you.
It would be helpful.